All right, so we are moving on with area of parallelograms today. And if you don't know what a parallelogram is, it's okay. All right, and today is the second. All right, so a parallelogram, once again, I've only got 15 minutes, so we're going to get through this. Parallelogram is a quadrilateral, which is a fancy word for saying it's a four-sided shape that has both parts of congruent and parallel lines. So what in the world does that mean? Well, what that means is, so envision a four-sided shape, and what I mean is both parts is that like the lines are congruent, which means they're the same length, and the lines are also going to be parallel. So let's just write down real quick. Congruent means having the same measurement. So they're the same length or the same width, whatever way you want to look at it, they're congruent. All right, and then parallel, hopefully you remember parallel means lines that never intersect or lines that never cross. All right, so here's an example of a parallelogram. Now, this is just an example. It doesn't mean this is how all parallelograms look. All right, so ideally, now mine's a little off because obviously I'm not perfect, but ideally what we mean is that both parts are congruent and both parts are parallel. So like, this is how you show that something's congruent in math. You call it a tick mark. So this has one tick mark and this has one tick mark. That means they're congruent. It means they're the same, okay? Now, I know this looks like all four sides are the same, but they're not. So we show that by doing, this one has two tick marks and this one has two tick marks. So that shows that those two are congruent. So you have to match up with whichever side has the same number of tick marks as you do. If all four of these had one tick mark, that would mean that all four sides are congruent. But that would be a rhombus. All right, so a lot of people confuse a parallelogram and a rhombus. A parallelogram is like a slanted rectangle. A rhombus is like a slanted square. Okay, so with a rhombus, all four sides are the same. Parallelogram, your top and bottom are the same, and then your sides are the same. We actually don't do a lot with rhombuses in sixth grade, but we do work with parallelograms. So the formula for the area of a parallelogram is you're going to do the area equals the base times, remember that dot means times the height. All right, this is different from length and width. So here's how you find the height. 9 times out of 10, they're going to show you the height by drawing a dotted line. So this right here is your height. And they're going to put a little box in the corner like that, showing you that it's a straight line, and that's the height. All right, and down here will be your base. Okay, think about when you go to the doctor and they take your height, they always ask you to stand straight up. Well, that's because if you're slanted, that's not an accurate representation of your height. So this slanted line right here is not going to be the height, okay, because you're not going to get your height from being slanted. You get your height by being straight up and down. So this dotted line right here shows the height. And when you put this little box right here, that box shows us a 90-degree angle or a right angle, which means it is perfectly straight. Okay, this dotted line right here is not a side of the figure. Okay, it's an imaginary line drawn to help you find the height. Okay, so all you'd have to do is to multiply this number down here times this number right here to get your area. So we can shorten that by just putting BH. When you have two letters side by side, it means they're multiplying. We're going to get more into that as the year goes on, but just when you see two letters side by side, it means they're multiplying. Now, a lot of times kids get confused because there's lots of numbers going on these shapes. Like they'll give you lots of different sides. I always tell my students, find the chair. Okay, and I know that sounds weird, but if you look, this right here kind of looks like a chair to me. All right. So like imagine this is a chair. Wherever your chair is, that's going to be the numbers that you need. Okay, and it'll make more sense once I show you an example. But if you always find your chair, that's going to give you the two numbers you need. What I mean by that is if this side right here had a number attached to it, is this side right here touching my chair? No, it's not. So that means I don't need this side. You only need the numbers that the chair is actually touching. Okay, so let's put this to some use with some numbers. The formula is pretty easy. It's always going to be base times height. You just got to remember which numbers to actually use. All right, so let's draw another one. Once again, it doesn't have to be perfect. But you do need to keep in mind when you're drawing it, the top needs to try to be the same length as the bottom, and the sides need to try to be the same length. So like these sides are congruent and these sides are congruent. But also remember it's a parallelogram. So these sides are parallel and these sides are parallel, which means if these lines were to continue, they would never cross each other. All right, so let me give you some numbers. So here's, remember they put that in there to show you the height. And I'm going to say this is 11 centimeters. I'm going to say this down here is 13 centimeters. And then I'm going to tell you over here that this is 12 centimeters. Okay? And remember my formula is area equals base times height. Okay? So let's look at it. I've been given three numbers, but remember my formula only requires two numbers. So something must be extra. Something must not be needed. I got to remember what that something is. Well, let's look at my chair. Remember, this is an imaginary line, but they draw it to help you find the height. Okay, so if that's my chair, what are the two numbers that's actually touching that chair? Okay, well, this slide right here is the back of my chair. Well, that side would be 11. And then this is where my chair is sitting. And what's that sitting on? It's sitting on 13. The only number that chair is not touching is this 12 over here. So that means I don't need the 12. It's just there to mess you up. So my base, where my chair is sitting, is 13 times the height of my chair is 11. All you do next is multiply those two numbers. 13 times 11 is 143 centimeters squared. And that's all I'm doing. Don't forget to put centimeters squared because we are finding area. Okay, let's look at another one. Move this up. All right, so this one, let's see, try to make it the same length. And then draw your lines. All right, there's my next parallelogram. Remember, these sides are parallel, these sides are parallel, and they're also congruent, okay? All right, so this time, they're going to tell you this side's 9 inches. I'm going to tell you that this side is 27 inches. And I'm going to tell you that this side over here is 10 inches. Okay? And remember, my formula is area equals base times height. All right, so find your chair. That's the first thing you always want to do is find that chair. That chair is always going to be wherever that right angle is. So I'm going to come over here. I see it right here. Okay? Now, what two numbers is that chair touching? One of them is easy to find because obviously this is the back of the chair. That 9 is obviously easy to find. Now, if you think about it, this is the bottom of a chair and you're like, oh, nothing's touching it. But remember, this whole line is right here. So that whole line is touching the bottom of your chair. Now, if you think about it also, if this side right here is 10, remember it's congruent. That would mean that this side right here is also 10, which might confuse some people. But even if it is, that is true. This side does equal 10. But even if you have it here, it's not touching my chair. This slanted side right here is not touching my chair at all. So I still don't need it. Okay, so that 10 is only there to mess you up. So the base of my chair, what my chair is sitting on, remember this line down here, the floor, you can think of it, is 27. And then the height of my chair was 9. So now I just multiply 27 times 9, and I get 243 inches squared. Okay? All right, we got one more for notes. All right. We've got all right, there's my parallelogram. Let me draw in the numbers. Now, these are things that they're always going to give you. You don't have to find these things. They're going to give them to you, or they're going to give you enough information to find them. All right, we're going to end with a tricky one. All right, so first step is always to find that chair. Okay, so I'm going to get my marker. All right, here's my chair. Well, hopefully the first thing you see is that this 8 does touch my chair, has a direct touch to it. Okay, well then normally I find what my chair is sitting on. Well, my chair is sitting on this line, but there's no number that goes with it. But remember, the definition of a parallelogram is that your sides are congruent, which means if this line up here is 11, then this line down here also has to be 11. Okay, and that's important because a lot of people jump to conclusions and just pick this 9 because it's close to the chair. But remember, this slanted side right here is not touching my chair. All right, in 6th grade math, you're not going to need that slanted side. We don't do anything with slanted sides. We need straight sides. Okay, so just ignore the slanted side. We do not need that number. Okay, all right, so the base of my chair, what my chair is sitting on, is 11. And then the height of my chair is 8. So then I just multiply those two, and I get 88 meters squared. So once again, just keep in mind, the two things you need to keep in mind is, one, find your chair, find the two numbers that are touching your chair, all right, and then ignore that slanted side, all right? When you're finding the area of shapes in 6th grade, you're not going to need a slanted side for the area, okay? So find your chair, find those two numbers, and then you just have to multiply them, all right? Thanks.